The Meet Your Microbit activity is a great way to get students new to the BBC Microbit excited about what it can do. Through an interactive exploration, you'll lead them in discovering some of the features of the microbit and help them spot what they already know about code. This activity reinforces the power of physical computing, taking coding concepts off the screen into physical devices you can hold in your hand, and builds on what your students are already learning. Let's look at it together. A smile. Fast and slow animation, a zooming square. It says hello. Hello, microbit. You might get a sun. You might get a moon. What's changing here? Ooh, surprise! To get started before your lesson, let's learn how to load the project code onto your microbit. Follow the link to the code and download the project from the MakeCode editor as a hex file. Plug a microbit into your computer's USB port using a micro USB cable. It should appear like a USB flash drive called microbit. Drag and drop the Meet Your Microbit hex file from your Downloads folder to the microbit drive. Before your lesson, load the project code onto your class microbits. You'll want at least one microbit for every 2 to 3 students. Now you can start your students' interactive exploration. Get them thinking about what computing concepts they already know that could be in the project code. If you have the microbit version 2, they'll also hear different sounds with each event on the built-in speaker output. If you have the microbit version 1, you can connect headphones using alligator clips to pin 0 and pin GND, ground, but this is not essential. You can run this activity without sound. You could ask your students to think about what kinds of information you can communicate with sound. Can sounds be happy, sad, fast, slow? Can sounds even say hello or goodbye? After you've explored the microbits, it's time to look at the code blocks together. You can use the simulator in the code editor as a giant virtual microbit to demonstrate what your students experience on the real microbits and talk about the coding concepts that make it work. Show icon happy is the first instruction, and the on-start block is the event that triggers it. So we see a happy face on the microbit when it's powered up. The 2 blocks of code tell the LED display what to show and allow us to see an output working. An output is how computers send information out into the world, such as the microbit's LED display. Now let's look at inputs. On button A pressed, on button B pressed, on button A plus B pressed, and on shake. These blocks all react to input events. They all make different things happen in code, but they each use a different physical input as a trigger. So let's look at the code for on button A pressed, the zooming square. The on button A press block monitors for when you press the button A input on the microbit. This event then triggers the instructions to play the sound output and display the zooming square animation. If you used sound in your exploration, look at the start melody block and listen to the sounds when you click on the buttons in the simulator. After the sound starts playing, a loop starts, repeating the animation 2 times. The display shows a square getting bigger quickly and getting smaller slowly. The sequence of images makes up the animation. The pause blocks keep images on the screen for different times. Smaller numbers make the animation faster, larger numbers make it slower. The on button B press block uses an input event to trigger instructions that clear the screen, pause briefly, then shows the word hello as a greeting on the LED display output. What else do your students think they could use that for? Pressing both buttons at the same time is the input event that triggers the instructions in the on button A plus B block. The program uses a conditional statement. If the light level is less than 50, then it shows a moon on the LED display output. Otherwise, it shows a sun. So this part of the code uses inputs from 2 buttons as an event to trigger the instructions to show you different pictures on the display output, depending on the amount of light around you. The light level is measured by another input, the light level block, which measures how much light is falling on the microbit using the LED display as a light sensor. So, the LED display works as a light sensor input and also an output to display our pictures and messages. What could your students build with a tiny computer that knows when it's light or dark around you? Finally, the on-shake block uses the microbit's accelerometer sensor to detect movement as an input event. It shows a surprise face, pauses for 1 second, and clears the screen. Ask your students what other technology they know that reacts to movement. How might you use movement in your own projects? Once your students have explored this code with you, they'll be ready to start working more independently on their own programs. You can use the step-by-step coding video to recreate this project, or pick any of the projects in the booklet. They've all been chosen to add physical computing projects relevant to the Learning in Code.org's CS Fundamentals courses. The Microsoft MakeCode editor works very much like block editors your students will already have used, and very soon they'll be creating, testing, and making real-world projects, taking computing concepts off the screen and into their hands.